Okay, so they wanted you to figure out what happens to the y's when the x values get bigger and bigger, or at the right side of the graph. And so some of you might put in a value. Some of you may have looked at the graph, but I put in like 100,000. And when I put in 100,000, I got 1 and then 15 zeros. So that's definitely getting bigger and bigger, right? And I'm just describing the y's similarly to the way they describe the x's. So if you worded it differently, it's okay. All right, and then the x values get more and more negative. And that's putting in a really, really small number, like negative 100,000. What did the y values do for that one? Get smaller and smaller. So I'm going to word it like they did. It doesn't matter. The y values get more and more negative. All right, now I'm going to use some notation that you may or may not remember from Algebra 2, but I think you will in the end. So if the x values are getting bigger and bigger, what are the x values approaching? What's the biggest number? It's not really a number, it's like a concept. Yeah, x is approaching infinity. And then the y values are getting bigger and bigger also, so they're approaching infinity. Okay, and then for B, the x values are getting more and more negative. What are they approaching? Negative infinity. And in this case, the y values are doing the same thing, also approaching negative infinity. Okay, and then this is a whole new different function, g. So as on g, as the x values get bigger and bigger, what are the y values doing? They're also getting bigger and bigger. All right, what about if the x values get more and more negative? Yeah, you're right. The y values are getting bigger and bigger. So sometimes that happens. The x gets smaller, the y gets bigger. All right, so for our notation, for A, the x is getting bigger and bigger, so approaching infinity, and so is the y. And then for B, the x is getting smaller and smaller, however, the y is getting bigger and bigger, so approaching positive infinity. Okay, and there is only one term in either one of these functions that matters when we're talking about what happens when x is really, really big or when x is really, really small. And it's the term that has the largest exponent. And so the next question says, based on your work above, how do you think the largest exponent in the function affects the behavior? So it's the one that determines if the y values approach positive or negative infinity. And it's because it has the most effect on what you plug in. So raising something to the fourth changes it a lot more, especially if it's a really, really big number. Changes it a lot more than raising something to the third or the second or the just raising it to the first. And so that is what determines what happens when the numbers are really, really big or small. And then number 4 says, what do you think would happen to the end behavior, so this positive or negative infinity, if the functions were reflected over the x-axis? So if your arrows were pointing up and you reflected over the x-axis, it's like Horns up, horns down. So they would be opposites. Well, do you think that shifting up or down or left or right would change what happens at the ends? So if it's pointing up both sides and you shift it around, does it change it? Yeah, it doesn't change it. Okay, so we're going to do this table, and then we're going to make our own table on the other side to help us always look at a polynomial and tell what happens at the ends. And so on this one, the highest exponent is a 2. That's also called the degree. All right, and then our coefficient to that term is a 3. And so this is a parabola. Would this parabola be opening upward or downward? Upward. So as on the left side, as x gets more and more negative, we're going to be still pointing up. The right side, as x gets bigger and bigger and bigger, we're going to be pointing up also. All right, and then this one, the degree, or the largest exponent, is 3. And this one, the leading coefficient, is -2. So it's going to be similar to this first one we did, except because of that negative, it's going to be flipped over the x-axis, so it's going to be opposite of what we got for that first one. And so on the negative side of x's, we're going to be going to positive infinity. When x is really, really big, we're going to be going to negative because it's flipped over the x-axis. All right, so let's look on the back. We're going to write 2 little sentences, and then under that we have to do a pretty large table. So leave yourself plenty of room underneath these 2 sentences. So like I said, there is only one term that matters when you're doing what we're doing today, figuring out what happens at the ends of the graph. And it is the one with the largest exponent. So it contains the leading coefficient. And what I like to tell my students, and I've been telling them this for a long time, and your Algebra 2 teacher probably told you the same thing or something really similar, but the leading coefficient tells what happens on the right. And so the right side of the graph is as x approaches, what do you guys think, positive infinity or negative infinity for the right? Positive. So if that leading coefficient is positive, the right's going to go up. If it's negative, the right's going to go down. So that takes care of the right side. How do you figure out the left side? Do you guys remember from Algebra 2? That's all right. The left side, you have to look at the degree, or the largest exponent. So the degree tells the left, which is when x approaches negative infinity. All right, so for leading coefficient, you decide positive or negative. For degree, you decide even or odd. And so an even degree is what we had for this one, so even degree, and for the second one. Right, and if you notice on both of those, the left and right were the same. So if the degree is even, the left is going to be the same as the right. And if the degree is odd, it's going to be opposite of the right. Okay, so we're going to draw a table. I really should have pre-drawn this table for you, but you'll be fine. Okay, so going down on the column on the left, we're going to say even degree and odd degree. So it's talking about the largest coefficient, largest exponent, sorry. And then across the top, oh, I need to extend this a little bit. All right, and then across the top we have positive leading coefficient. And negative leading coefficient. All right, so I know that the leading coefficient tells me what happens on the right side of the graph. And so if this column right here, where I have a positive leading coefficient, I know that the right side is going to point up. So I'm just going to go ahead and draw my right side pointing up there. And I know that the column that has negative leading coefficient, the right side is going to point down. Okay, so then I have to figure out the left side. So if the degree is even, then that means that my arrows are going to point in the same direction. And so for even degree, the left side matches the right side. And then for odd degree, we're going to have opposite directions. And so the left side will point in the opposite direction of the right side. All right, and then there's one more thing I'm going to fit in this table, and it's going to be those statements, like the as x approaches infinity, all that stuff. All right, so I'm going to start with this table right here, or that box right there. As x approaches negative infinity is the left side, and that arrow is pointing up, so it'll be positive infinity. And then approaching positive infinity is the right side, and that arrow is also pointing up. So see if you guys can do those statements on your own. I'm just going to kind of fill them in without talking. I think you probably can do it. So just remember, all you need to make these decisions is to look at the first term, the term that has the largest exponent. Okay, so we're going to do 4 examples. In this first one, we don't have the equation, but we have the graph, which is even better. And so we're going to describe the end behavior of this graph. And so I'm going to start with the left side. The left side is as x approaches negative infinity. What is the function approaching on the left side? Infinity or negative infinity? It's pointing up. It's going to be infinity. What about the right side? Also infinity, yes. Good job. All right, and then number 2 says, is it possible for this graph that we just talked about, for it to be degree 5? So if it's degree 5, 5 is odd, right? Can the arrows both be pointing up on odd? No. So odd degree must point in opposite directions. Okay, now I really like this question, but it does make you think. Number 3. So it says, which of the following terms, when added to this polynomial, would change the end behavior? And we're going to check all of them. There's more than one that does. And so the only way that adding something would change the end behavior is if it somehow changed the term with the largest exponent. So anything other than changing this is not going to work. All right? So would adding negative x to the 8th, would that change the degree? Yes. So it would change it. It would be going from being like this to being like this. So it would definitely change it. All right, what about adding negative 3x to the 5th? Nope. What about adding 5x to the 7th? It would change it, because it would change that to a 3x to the 7th, which is going to change the positive negative leading coefficient. What about adding 1,000? Nope. Negative 300? No. So it would only change it if it changes something with that leading term. All right. And then on this one, we're going to do this just out of our head, not using a calculator at all. So we are going to match these graphs. So you guys look at one and decide which way the arrows go. And you can just draw little arrows if you want to. So just a reminder, the leading coefficient tells the right side. So what's the right side going to do? Don't use a calculator. The leading coefficient tells the right side. So what's the right side going to do? Is the leading coefficient negative? So it's going to go down on the right. All right, then the degree tells the left. So the degree is odd. An odd number, is it going to go the same or opposite? Opposite. So which one are we looking at? That's C. Good. All right, and then we get to 2. The leading coefficient is positive. So that means the right side is up or down? Yes. The degree is odd. So the left side is down, the opposite. So what do y'all think? Good. All right, try 3 and 4 on your own.